Hello, scientists. It's Miss Brown. So I'm back for another week of science and technology. I hope you enjoy our technology. Are we ready to get started? This week I'm excited because I get to share with you a really cool online program called Nearpod. So I did our science and technology learning in slides this week, and I'm going to show you how the slides can be shared in Nearpod. So Nearpod allows you to create media inside your slides, such as questions or videos. We can look at it either together or separate. And so I'm going to walk through and show you what different features in Nearpod are. But if at some point you want to join along, you can use the code. You go to join.nearpod.com and you can just put in the code IAEBL, or you can go to the app. And so that's how you join and look at the slides on your own and do the activities on your own. But I'm going to show you how to do them today. So this is where our science slides start. Let's go ahead and look at our slides in Nearpod. Okay, hello scientists. So this is Nearpod. This is what our slides look like. They look the same, except for there'll be some activities coming up and I'll show you how to use them. So last week we learned about how to change sound. Did you make a musical instrument? Did you make sound with it? This week we're going to talk about what is light and what is reflection. What is light? Light is bright. Light is radiation that can be seen with our eyes. Light is seen during the day when the sun is out. Light is waves that we can see as colors. Light can be absorbed. Absorb means a plant takes in the light from the sun. We only see that the leaf is green. We don't see any of the other colors because all those colors have been absorbed by the green leaf. Light can also be reflected. When light reaches the mirror, the light bounces off to the wall. So you can see in the picture the flashlight is sending the light to the mirror, and then the mirror is reflecting that light against the wall. What is reflection? Reflection occurs when light bounces off a polished surface, like a mirror, and changes its direction. Do you have a flashlight and a mirror at home? You can try making light bounce off of your mirror, and you can try making a reflection and bouncing that light onto the wall. This is where Nearpod can be really cool and useful. So I put a question in here, and so if you were logged in and you used your code, you would be able to answer this question. Where did you find a flashlight and mirror at home? So I can embed questions in my slides. Water. Water reflects the mountains and rocks around it. It's as if water was its own mirror. Next time you see water, look for a reflection. Here's another question I embedded into Nearpod. Where can you go to see water and reflections? Can you think of a place? If you go to Nearpod and put in your code, you would be able to put an answer right here. Where else can we see light or reflections? Look around the house. Is there anywhere that you see light coming in? That you see reflections? Let's watch a video and learn more. So we're going to watch our video together.
Caught your own reflection in a mirror, window, or pond and wondered, how do mirrors actually work? Let's find out on today's episode of Colossal Questions. The truth is, mirrors are just as old as anything. Any smooth surface that can bounce back light can be used as a mirror. The very first mirrors used by humans would have been dark pools of still water that could reflect their face back at them. But how does that work? Why is it that smooth surfaces can reflect images back at us? It has to do with the way light hits a surface. You see, when light shines off an object, like your face, and hits a super smooth surface, the rays of light can all bounce back at the same exact angle. Our eyes perceive this perfectly reflected light as a mirror image, meaning it looks just like you, but backwards. Rough surfaces bounce back light at all different angles, so we don't get any mirror image at all. But not every smooth surface acts like a mirror. If the smooth surface absorbs the photons instead of bouncing them back, there's no reflection. The earliest known examples of ancient mirrors are more than 8,000 years old. Found in modern-day Turkey, these primitive mirrors were made out of a polished volcanic glass called obsidian. By 3000 BCE, mirrors of polished copper were available to the wealthy people of the Mediterranean, but they were prone to being blurry and regularly needed polishing. Modern mirrors were invented in the 1500s, when Venetian craftsmen started coating clear, even panes of glass with a thin layer of tin and mercury mixed together, which made for a near-perfect reflection that needed no polishing. Today, mirrors are made of manufactured glass that's been coated with either silver or aluminum on one side. Factory precision allows almost every mirror to perfectly reflect the image back, making it a bit less of an art. Unless, of course, you're lucky enough to make mirrors for a carnival funhouse. And now you know a little more about how mirrors work.
How do mirrors work? This is where I put in another question for you. So that is our video. What did you think about Nearpod? Is it pretty cool? I think so. Something else that's really cool about Nearpod is that we can go on virtual field trips. And so this is the Taj Mahal, a huge palace in India. And it's at sunset. What do you notice about the light? Do you think that there is a lot of reflection this time of day? So this is just before the sun goes down at sunset. Where do you think the most reflection is going to be? Look at this really cool tall tower. What's really cool about taking a virtual field trip is we can look from different angles. Whoa. Look at all these people. Thank you for joining me. Don't forget, if you want to go to Nearpod, join.nearpod.com and the code. Did you learn a lot today? Good job. Thank you for joining me. I'll see you next time.